Hello, let's go ahead and be looking at part B of this question on number 3. So part B says find the initial velocity of the bullet before the collision. Okay, so we already know that from part A, okay, that the initial velocity of the block, so basically that is my final velocity, right? So I'm looking at what's happening after the collision, right? And so it was the initial velocity of part A, but it's really the final velocity of part B, right? Part A is going from the bullet is separate, and so now it's inside the block. That's part B, right? Is going from the bullet separate, now it's inside the block. But part A is going from the block bullet system, right, at the top of this table, falling down, okay? And so for part B, this velocity here is now our final velocity. So we have x root g over 2h, okay? And so that's my final velocity, and so I want to set up my momentum. So setting up my momentum, the sum of my initial momentum is equal to the sum of my final momentum. How many objects do I have moving before the collision? Well, just the bullet, so m v naught equals, and then at the end I have how many objects moving? 1, but they're now attached, so I'll have m plus m. Okay, I'm going to go up and see if they give us some masses for these objects, and so you'll actually see the block has a mass of capital M from that diagram, and then the bullet has a mass of lowercase m. Okay, so I will make sure I make this a nice big tall M. Okay, and then this velocity here will be my VF, and I will plug in here from that part A in a second. Okay, so this is part B, right? Okay, let me put some dotted lines here just to differentiate between A and B. Okay, and so now I just have V naught, so my initial velocity is m plus capital M, and then I have x root g over 2h all over lowercase m. And so that actually is not too hard of a question. It's just a setting up my momentum. Okay, and so I will see you back for part C in one moment.